Yeah, this will be weird to walk.
I just hold it close. Alright. Yeah, man. I'll take it. I'll miss you guys, but alright. You're gonna suffer.
We got
You guys took Corey. Took Corey to death.
I know. Hey, how you doing?
I'm gonna tell you.
Okay, thank you.
My little sword isn't working. Like it just keeps, I guess, running.
I guess we're in an infinite limit. So, that's what do you want me to help you?
Could you?
Got it, yeah. This won't work.
It won't work.
Put them both in an array.
Okay.
Trying to do like the fancy object destructuring way.
Yeah.
So let's wrap an array around those and see if that helps us.
So it's better to use the policy.
Right.
Right.
Oh, okay. That was-
Okay.
All right, thank you.
No problem.
Can you click on the yellow box so it's not like covering some of the text?
How do I guess I have to reload it.
So while it's not, while it's not sorted.
Thank you.
Yeah, no problem. Thanks for the heads up.
So here's a good description.
Why do I have to put in it?
Yeah.
I mean, I don't know if those things answer, but it's like JavaScript.
Okay.
So like it's just the way that if we can't do variable reassignment with like two variables on this side and this side, unless they're in arrays, because then I think when the arrays are like in kind of an object, because you can also do it with the actual object.
Mhm.
And like for some reason that's okay.
Okay.
I know. That's not the best. So I'm gonna do 5 more minutes for Bubble Store, and then we can go through Bubble Store, and then we'll give some more time for the other ones. Okay?
You could almost do bubble Bubble Store is larger or smaller. So smaller numbers can be on +1, +1.
This variable to whether that's what we're looking at here. Just
So I should. Oh.
Yes, he plays.
I thought it sorted it far back.
Oh man, whoops. All right, clap your hands if you can hear my voice. Bingo. Jasmine, did you want to make it? Jasmine was going to make a quick announcement.
Yeah, hi everybody.
Hello.
Yeah, hi Jess. Thank you. Just wanted to clear some things up. So, as you know, we had a family emergency. He is coming back. He is intending to come back Wednesday, but you know, obviously, he's out west with his family. He's he's having enough time. So, hopefully, we can get him back Wednesday. If not, hopefully, within a week. But he is coming back. So I want everyone to like calm down, please abandon us. We're just going through a lot right now. So if anyone has any more questions, obviously we can't disclose like his personal business, but I hope that's about it.
Okay, now back up here because we're going to do it. Okay, so let's talk about Bulbasaur. How do we do on Bulbasaur? I know it's been a week. Yay, nay, okay. Mostly nays and yays and okays. A little bit of a mix. Okay, so that's fair, right? We went over one time pretty quickly, and it's been a week. So let's talk about it. Let's write it together, and then we'll worry about the next ones. So we started with a function, right? So const, it's called buffer sort. I like that. And took an array. And okay, so we got this bubble sort going, and can somebody kind of like give me like an outline of what we need to do? Like, what's the kind of concept behind it? It's the same one that Trey gave last week. If that helps. It's also what we've been working on for the last half hour. All right, go for it.
Taking in the array and we're gonna compare the elements, like which one's less than or greater than, and then if one is greater, we kind of want to move it into a sorted array, I think. I'm not sure. Like,
Awesome.
what's happening.
Yeah. Okay. So that's a great answer. Both of those, the answer and the I'm not sure. I like both of them. Okay, so the idea is like, let's say we have this array. I go 1, 3, 5, 4. We are going to go. Okay, we're going to compare the 3 and the 1. The 3 is larger than the 1, so these are going to swap positions. Oops, 1 and 3. And now we're still here, and we go 3 or 5. This, which one's greater? And we're going to say, you know, the 5 is still greater. So the 5 continues on. It goes 5 or 4, which one's greater? Well, 5 is greater. So they swap positions. And then we have to check again. This is a pretty clean example. So then we get checks 1 and 3, that's good. Checks 3 and 4, that's good. Checks 4 and 5, that's good. Then it's done. So it returns the sorted array. So that's what's happening. So let's, if I were to write one, right? If I were to write it like that, we would be checking. Okay, it's the 5 and the 4. And we say, all right, the 5 continues. So we swap 5 and 3. 5 continues. They swap. 5 and 2, they swap. 5 and 1, they swap. And then it goes again. I'm not going to, it gets a little laborious, but the point is that it's going to keep going over and over again. It's going to keep, and it's only going to keep going as long as the swap is taking place. So far, so good? All right. So with that in mind, we got to have some idea about whether or not we've made a swap. Because if we've made it all the way through the end and we haven't made a swap, it's safe to assume that it's sorted. Is that a fair statement? I'll say it again. If we go all the way through the array and we never swapped 2 pieces of information, the array must be sorted. We can agree on that? Okay. So we got to keep track if we've made a swap. So I'm going to create a variable called, I'm going to say let not sorted equal to true. And so, and then I need to continue to do this pattern while it's not sorted. Right? Okay. So I say while not sorted. And then this is where the bulk of the logic has to come in. But I have to turn this, I have to have a way to escape this while loop eventually, which we kind of talked about, this idea that once I've gone all the way through it, if I haven't made a swap, then I want to stop. I want to break out of the while loop. But we can't keep switching sorted to true or false just based on whether or not we've made a swap. We want to always make it true if we've made a swap. But if we haven't made a swap, we have to make a false somewhere, right? So the place I'm going to make it false is going to be before I even go and do my loop. So that way, when I'll have a clean slate, I'll go all the way through my loops. If I never made a swap, I will then break out of my while loop. Otherwise, I'm gonna change sorted back to true, and I'll go through the for loop again. So let's kind of just see it a little bit. Oh man, this is kind of weird. Okay, so I can change it here. This is kind of the way to ensure that we're starting with this clean slate before we go into a for loop. And we can say for, let I equal 0, I is that length, I plus. Okay, so now I got to just do a little bit of lot. Are we, any questions on what we have on the board so far? Okay, so now we got to do a little logic. What do we need to look for? What's the goal here? Yeah, Trey.
I was starting here. First,
I like that. So Trey says we got to compare our indices, our elements at the indices. So if I say, this sounds like a condition, right? So we say if array at I is greater than, because if it's greater than, we got to swap it with array at I plus 1. What do we do?
Temporary.
Okay. Tell me the whole process, Max.
So the temporary will equal the second one, the array at I plus 1. We're gonna swap that with array at I, and then we're gonna swap array at I with 10.
Exactly. So Max is saying we're going to create this temporary variable to keep track of the one we're going to be swapping out so that we'll be able to switch all of the values. So if we say temp at array at I plus 1, we can then change the value of I plus 1 safely, right, without losing any information, to array at I. And then we have to update our array at I, but we still have the value that this used to be because we have an intent. So we can say what else? What else do we need? Thomas?
Not my answer, but under the statement, should be not sorted equals true.
Yeah. So we've made a swap, right? If we've hit this if statement and we've done this information, we've swapped pieces. So if we swap pieces, are we 100% sure that our array is sorted? No, right? So we have to change our variable back to not sorted. True. That way, when we finish this for loop, we'll hit the while loop and we'll get to do it again. Yeah, Crispina.
I remember asking this exact same question before. I
Cool.
guess I still don't
That's okay.
understand it. So we're starting with not sorted is true,
Mm-hmm.
and that's allowing us to get into the while loop. I understand that.
Yes.
Then we reassign it to false. And I don't understand why we're doing that in the beginning, and then we're reassigning it to true again. at the
Cool.
end.
Okay. So the question is really about this mysterious line at line 19. And the idea is, okay, eventually we got to get out of this while loop, right? Eventually. We have to get out of the while loop or else we're going to be here till tomorrow waiting for it to sort 4 elements. And beyond. We're going to die of old age, right? We don't have the time. So we have to break out of the while loop eventually. And so at some point, not sorted has to be false. And we can think about where can we make not sorted false. We have to think, where does it make sense to make not sorted false? If we make not sorted false at the end, after our for loop, then as soon as we gone through the for loop, even if we did make a swap, not sorted would be reassigned to false, and we would leave the while loop after the first iteration. But putting it at the top, we have like this clean slate, so to speak, so that we can then go all the way through all of the elements and check if there's any swaps. If there's any swaps, we're going to want to run that while loop again, so we have to reassign it to true. If there's no swaps, only then do we want to exit. So there's just no other place that we could put this and still have our code work.
I'm gonna try to say that back to you. And
Yeah.
I don't know if I'm gonna do it. So we're getting into the while loop with it being true in the first place,
Mm-hmm.
and we want to like check. We want to go through the for loop, and we want to check all the elements and stuff, like this whole big thing of things that's happening. And we want to like do that repeatedly. So we're setting it to false before we do that, so we can get out of the while loop, I guess. But I guess I can't tell you why it's true inside the for loop.
Okay. That's great. That one's an easier one to answer, actually. So we put it not sorted true inside of the for loop because we've made a swap. We only reassign the value to true, like that it's still not sorted, if we've made a swap. Because if we've made a swap, we can't be totally sure that our array is sorted. If we've made even one swap, our array might not be done. So we have to set it up to true so that we'll hit the while loop and go through it again. Diana.
Can I try to explain that?
Yeah,
So if
that
you-
sounds great.
So right now that like let's say we have 4, 3, 2, 1, 5. So if we just compare 4 is bigger than 3, so that's just one swap, right? But because it was false, if we didn't put not sorted equals true again, then it's gonna exit and it's just gonna give us back 3, 4, 2, 1, 5. So it will not be sorted completely.
Basically, we keep going until we completely like hit false. And when it's, I guess when we go through the whole array, and when I is going to be equal to array length, we're not going to do the if thing. So we're not going to change it to true. So it's going to stay false, so we can return.
Yeah, the way I work is that I need to like sit with it, so thank you for your time.
Okay. Cool. Yeah, experiment with the placement, a bit of all the elements, and maybe that will help. We still have one more thing to do here, right? Right?
Return the array.
Where would we want to return our array?
At the outside of the while, or inside the while black hole. Right there, right at line 19.
Right here?
Yeah.
That's outside the while loop. Good. All right, let's try our bubble sort. See what kind of big reds we've got coming.
Got the U.
Can I spell it? Oh, boo boo. Baboo. Hey, baboo. All right. Okay, it works. Trey.
So on my part, the variable temp, right? Is that keep track of the next index?
Mm-hmm. Oh, the next element at that next index, yeah. Otherwise, when we go to swap it, if we change this value to this, we wouldn't have any way to know what this was to give it to the value of array I. Okay, so let's spend another 10 minutes on merge and merge sort. Because then I want to go over quick sort and make sure you guys get a lot of time to whiteboard today. That's my goal. That way we're on the same page with my goals. Okay, so if we just a brief recap for merging, right? We're taking two sorted arrays. That's necessary. Our merge function will take in two sorted arrays and return a merged version of those sorted arrays. Okay, so no sorting inside of there. Yeah.
Are we using the bubble sort?
No, we don't need to use bubble sort anymore. This merge is just taking two arrays that are already sorted and merging them into one bigger sorted array. And then we're going to write merge sort, which will use our merge function. Okay, but start with merge, and then we can talk about merge sort. Question?
Return the array.
Right. It's okay.
Well, I guess that's what I'm trying to show you.
Really? I shared it with someone who not.
Instead of, we're not, instead of praise, she give you some.
Yeah. Thank you.
Oh, I don't know how to pick 10. I have no idea how to work Yeah, no, I have, no, before.
Oh,
I don't know why.
You said that you got lucky that it only needed one iteration. I don't know what that means.
It'll. Yeah, sure.
Or 5, 3, 5, 3, and 5 and 3 switch, and then 1, 2, 3, and then 5 and 4 switch.
Oh, right.
1, 2, 3, 4, 5.
Oh,
And then, but we didn't have to do that.
Oh.
And we did like 5, 4, 3, 2, 5.
You can switch which means.
1, and then we could return to our 4.
So it would break it if I put like 1 all the way to the end. Yeah, okay.
We're just getting lucky.
Yeah, right.
Had a good sound.
So, you know, towards everybody, you know, guys try to send, right? The problem inside. And that's everyone like, that's what you do. It's gonna be.
Oh, you're right.
We can always shout it.
The rest of it's working right. Just gonna put it outside of the bottle. Doing that, still they're already all.
I don't understand that.
Was it you last time?
All right, clap once if you can hear my voice. All right, let's do the merge, and then we'll talk about merge sort again. Okay, so we got. I'm gonna write here, so I like both. Okay, so we've taken in merge. This takes in array 1 and array 2. Can anyone tell me something unique about these two arrays? Yeah, thank you, Johnny. Johnny says, hey, they're sorted. So if they're already sorted, what does that mean? Like, how can that help us when we go to merge two arrays? If we know they're both sorted, how can that be advantageous to us? Kia? Yeah, exactly. Takia says that since they're both sorted, the smallest element in each array is the first element in each array, always. So we can compare exactly just that first element in the array and move it into an output array continuously. Okay, so let's do something like that. We're also going to need some kind of, we're going to need to keep doing it, right? So we have to have some sort of loop because we're going to compare, put that one in, compare, put that one in, right? We're going to keep doing that. So we have to loop. And also have an output array. What's a good loop for this kind of situation? What kind of loop? While loop? Yeah. How come? Because you remember? Okay. Can anyone else tell me why we want it? Trey?
While a certain condition you wanted to.
Yeah, but why do we want to use a while loop over a for loop? It's kind of a... Crispina?
The for loop would just go from like the beginning of the race to the end of the race, I guess. The while loop would be using the condition to keep going.
Yeah, that's a good way to look at it, right? Our for loop is like iterating through numbers, pretty much like that's pretty much all the ways we've been using for loops and the way they're generally used. While our while loop is more about checking specific conditions and not necessarily worrying about numbers, so to speak. So, okay, so let's throw in a while. We got to come up with a condition. How long do we want this to run for?
As long as there is an array.
As long as there's
As long as there is something in the array.
which array?
Oh,
As long as there's something in both arrays? Okay, what will happen when there isn't something in one of the arrays? It's okay. You're right though. So Nikki says we want to keep this loop while there's elements in both arrays. Because if there's not elements in both arrays, because right, no matter what, one array is going to finish before the other array, even if they're the exact same number, right? I've got the number 1, got the number 1, right? And I'm going to push something into output. No matter which one I choose here, one of them is going in, right? So let's say this one's the lucky one today, and now output has a 1 in there. Now, like, there's nothing to compare, right? It's just going to freak out. Yeah, Renat?
But is it going to say that this one is smaller than this one? Like
I think it's going to say you can't compare something to undefined. I think you'll get an error.
So is it going to break the code or is it just going to exit the while?
I think it's going to break the code.
Okay.
But we can try. Okay. So we're going to write it correctly, and then we'll switch it up and see how things react when we break it. So while they both have a length, so while array of 1 dot length, I could write greater than 0, but length can't be negative, and 0 is a falsy value. So I can just leave it at while array 1 dot length. And array 2 dot length, same reasoning. It's not going to be negative because that doesn't make sense. When it's 0, it'll become a falsy value, so that this will stop anyway. So I can assume that any other length is truthy. Therefore, I can just write array 2 dot length. And like Takia said, I think it was Takia who said this, we're going to be comparing at the 0th index. So we can say if array 1 at 0 is less than array 2 at 0. What do we want to do? Yeah, okay. We're going to do output dot push. How can we take off the first element? Yeah, we can shift it. So I can say array 1 dot shift So this is removing the first element on array 1 and pushing it into our array, output array. Else, just the opposite of that, right? It's going to be output dot push array 2 dot shift. Okay. So, what's next? Yeah, Janelle.
Return,
Return, what do we want to return?
output.
Sure, let's try it. Okay, we're not quite done, but let's see how it works, and then we will worry about Renat's question. So we go merge, and let's say I go 1, 2. Actually, I'll make it a little bit more interesting. 1, 3, and I'll take a 2. Do I have any writing anywhere? I do. Try again. So we just get the array back of 1, 2. Why did that happen? What?
We didn't put them together. So that's the cat.
Yeah, exactly. So Janelle says we didn't put them together. And I think what she's talking about is, right, the 1 got removed, then the 2 got removed, and then our while loop ended, and we still had an array with 3 left. So we have an empty array and an array with 3. So instead of just returning the output, I'm going to return all of the remaining things concatenated together. So array 1, concat, 2. And now we're good. JR.
Are we worried about any duplicates in this case?
Are we worried about any duplicates?
Yeah. Like array 1 or 2 actually have like the same. Yeah, we like built anything.
No, it would still work. It will just check if it's less than. If it's not, it will just go to the other array first. Good question. Renat, so let's say, okay, so we know array 1's length is going to, array 2's length is going to finish first, right? So I'll just say while array 1 has length, and we'll see if it throws that error. Or I guess it just freaks out. Oh, eventually it freaks out. Not liking it.
What if you store array 1 and array 2 into a variable and variable as contents?
What do you mean?
The argument is array 1 and 2. You store them into a variable, and while the variable has contents.
Yeah, I guess it's possible. I would argue that array 1 and 2 are currently already variables.
I guess to make it like, instead of writing an end statement, kind of work what we're not saying, have this one
I
word.
think that would be more confusing because you would still have to have content having something. I'm gonna leave it like this for now. Any other questions on how merge is working? Yeah, Christina.
So, the comment was making me think about this comment.
Okay. I forgot what his comment was.
It was, thinking about
Okay.
So can you show the array on the bottom? So what if it was like 1 and 1 and 1, and we didn't have like greater or less than in any of them?
That's fine.
We would still do it?
Yep.
Oh.
See, it just would go, is this one less than this one? Nope. So it would just shift from this one, and we'd have an empty.
Okay.
Our while loop would end. We would output our array of 1 here, concat it to our array of 2 1s, and then concat with another empty array. Ben.
What if the condition was you merge the shape with its
Um, If you wanted to merge and not have any duplicates, I'd probably merge it this way, and then I'd probably loop through it again and put them all in a set or an object, like our no dupes problem from Unit 1. Practice problem, I forget the number. David.
If you were in a situation where they weren't sorted, there are ways to like go about the same increments through both arrays.
I don't think so. Not that I'm seeing, because we don't know what's coming. I think you'd have to just bite the bullet and sort them all. Okay, now let's take another 10. I'm trying to think. Maybe we'll just go into merge and then we'll talk about quick sort, merge sort. Let's talk about merge sort. Let's just walk through it together. So merge sort, can anyone tell me what the goal of that and how that one's working? Sure.
You taking two arrays that are unsorted, and sort them. Sort two arrays separately.
Sorta. Not bad. So it's only going to take in one array. And I'll draw this one out. So merge sort's all about divide and conquer, right? So we've got an array that's like 3, 4, 1, 2, 5. And we go, okay, let's take the left side. So we're going to go 3, 4, 1. Let's take the right side. 2, 5. Let's take the left side of this and we go 3, 4. And let's have the right side, which is 1. Let's take the left side. Let's take the right side. Let's take the left side. Let's take the right side. So now we've got all of these arrays of the line 1. Are these sorted?
Yes.
I'd say so, right? These are already sorted arrays. So now, if we were to call like a merge function on them, we could pass 3 and 4, and this would give us back this nice 3 and 4. This would return this 1. This would return this, we could pass in this 2 and 5, and then this would, well, these were already sorted too, so this would return that after they've been merged. Then these would become merged, and this would return, after they've been merged, 1, 3, and 4, right, using our merge for comparison to arrays. And then we'll have 2 arrays here, and then these get merged. So it'd be 1, 1, 2, 3, 4, and then the 5. So we keep splitting it up until they're already sorted, and then it sorts them back continuously as we double up. Merge sort, divide and conquer. Okay, so let's write it. Let's do it. Who said it? Yeah.
I kind of remember last time you didn't account for an odd number of elements, yes? So you were trying to get that middle point, or was it over the white out?
Oh, so if there's no middle point, you can just like choose for like what you want the middle point to be. Like if there's 2 get passed over here and 1 get passed over here, that's fine. 1 passed over here, 2 passed over here. That's fine. It's kind of like the dealer's choice. So if we were to write merge sort, gone, merge sort takes in an array. And what kind of function is merge sort? Recursive function, yeah. What are a couple things recursive functions need to do? Base case is usually the first thing we see. What's the other mandatory thing? Jenya was faster. She said it has to call itself. Okay, so let's start with that base case. So when was a good base case? Based off of what we did on the board, when should we stop? Yeah, when the array length is 1 or less, right? If somehow an empty array gets passed in, that's fine too. So we say if array.length is less than or equal to 1, we can just return the array. All right, we got like a quarter of the problem here. So if we remember what our next step was, as we were going down that board, what did we have to do? Can someone raise their hand? Bang. Where? Okay. Yeah. So let's. Yeah, we will. So we'll get the middle index, and we'll say math.floor, and we'll say array.length divided by 2. Can anyone tell me why we use math.floor? Abed? Yeah. Yeah, right. Because if our array was length 5 and our middle index was then 2.5, that'd be kind of a funny array to key into because they're indexed in integers. So we go, all right, we got our mid index. So we have to split it up. So we have to have a left side and a right side. Left side. What's a good left side for this? How can I split this? Michelle? I like that. So we'll say array.slice 0 to mid index. Let's do right side. How do I get the right side? Slice it again. All right. Seems good. Okay, so now's the tricky part if we remember. What's next? What do we have to do? Kia? Cool. Sounds great. So Takia says we have to sort our left side and our right side, and we can do that by calling merge sort. So we can say let left sorted equal merge sort of left side and left right sorted equal merge sort of right side.
Your merge sort is called merge sort at the top, and yeah, your side. There you go. At the very, very top.
Okay, I see. Thank you.
Right, so it is also.
Right here. Is my spelling good now? Okay, thank you guys. Oh, you have no idea how much time I waste with spelling stuff. Well, you might now. You might be getting an idea. You guys are saving me hours. Although to be completely fair, it's a little harder to like code and look that way. So I'm prone to making more errors. I have to get better at typing. So, okay. So we've got our recursive calls. We've got like our inductive step for the most part. We've got our base case. What are we missing from this function? What's a piece of this function that we have in like every function that we're missing? A return? I heard some mumbles. All right, so we got to return something. What do we want to return? Okay.
Animation of sorted by.
Maybe, not quite. We still haven't used the merge function. Andre?
I just had a question about,
Oh, yeah.
sort of trying for calling merge sort on each of the split arrays, but how is that sorting?
It's gonna keep,
You're gonna do the
it's
same
gonna keep
process over and
splitting
over?
all the way over and over again. Each call until they eventually turn one. But we're missing one more step, which will then put everything back together. What do we have to put things together? We have merge. What does merge take in? What about those arguments is special? Takes in two sorted arrays, right? Well, heck, we got two sorted arrays. Right? With left sorted and right sorted. Well, we got that. Maybe it
I
works.
don't understand why they are sorted, we just kept switching them, but nothing for
This did.
this sorts them, merge sorts them.
It sorted them once they hit a length of 1. I'll do the stack trace again in a minute. Okay, so we got like 45. And we get an error. Reference error, more sorted. Good. Keeps me honest. Okay, awesome. Working. For not, let's do yours. Let's talk about it.
Corey, can I ask,
Yes.
is it the bubbling up that's sorting it?
Great question. For those of you who didn't hear that, because it's definitely something to hear, she asked if it's the bubbling up that's sorting it. And it is. Right? Keeps splitting up, it makes this like, and then it goes. So, without the sound effects, let's do it. Okay, so let's pretend we have 3, 4, 1, 2. Let's just fit. Close. I take the left side. Right, this hits already at length 1 now, right? So we're gonna take the middle, which is 2. I'm just gonna eyeball it, okay? And we're gonna take the left side, and our left side is 3 and 4. So we go LS, 3 and 4, and we have RS is 1, 2, and then we call merge sort on our left side. So this doesn't hit our base case, and this creates its own left side, and it says, takes the middle and it goes LS is 3, RS is 4, and in this call, it would call merge sort now on this side, and this returns that, right? So now this is left sorted, now this. This called merge sort on this returns just a 4, so now this is right sorted, and then we merge these together, it returns 3, 4. And now we are back to this right side where we call merge sort on here. And this slices it on its left side. So we have an LS, which points to a 1. And we have an RS, which points to 2. And then we call merge sort on these. And this returns just that 1 again. So say it's sorted. RS returns an array of 2. We're passing just an array of 2 in there. So now we have our right sorted. And then we return the merge of these. And this merges to 1, 2. And now we're back here. So now these are now our outputs, and this is now left sorted and right sorted. And then we return merge of these. And we get 1, 2, 3, 4. Christina.
So line 51, the where it says merge is actually a method, like a set method
It's
that's.
a function that we wrote previously.
Oh, okay.
Does that help clear up the call stack there? Okay, let's learn another sort. This sort is called quick sort. I like it because of its name. It's kind of cool. So quick sort is a fun sort. So quick sort works like this. So we have 3, 1, 2, 5, and 4. Ideally, quicksort will take a random pivot, but for now, I'm just going to take the last number because it's going to keep things consistent for us. All right, so quicksort chooses a pivot. So I'm going to say pivot, and I'm going to choose the last number in the array. And for now, I'm just going to remove it from our array. So I have pivot. Now, what we do in quicksort is we're going to create a side, we're going to create the left side and the right side of that pivot. So we don't split it evenly, we're actually going to iterate through it. So I'm going to have a left side array, and I'm going to have a right side array. I'm going to iterate through this. And I'm going to go 3, left or right of the pivot. Left, so I'm going to go 3, 1, left or right of the pivot. Left. 2, left or right of the pivot? Left. And 5, left or right of the pivot? Right. Okay, so that. So now, I know for sure that if I have a left side here, I'm going to represent it there. I have a pivot and a right side. I know for sure that this is in the correct place. Okay? So if I call quicksort on my left side and my right side again, it's going to happen again until everything's already put into place. So let's see if I can show this visually. So for this round, I'm gonna say left side 3, 1, 2. Pivot is 4. Right side is 5. Okay? So these are we're gonna call quicksort on this, and we're gonna call quicksort on this. Okay? So we look at this, we're gonna grab a pivot. Our pivot is gonna be a 2. And we're gonna create a left side and a right side. So we're gonna iterate through it. And I'm going to say, hey, 3 less than or greater than our pivot. Right, it's greater than. So I'm going to put this inside of our right side. I'm going to say, I should have taken out the 2 when I made the pivot. I'm going to say, hey, is 1 greater than or less than our pivot? Less than. So that goes over here. Okay. And then, on our right side call over here, mode, that's already sorted, right? This is the same kind of basics. It's just empty, it's sorted. So if we actually look at the leaves of this tree here, we can see it's already sorted. We've got a 1, 2, 3, 4, and 5. So if it returns, once the length is 1, so let's say this is going to call quicksort, right, on 1, and this is going to return an empty array of 1. We're going to concat that with our 2. So then this gets concated to 2. This also returns an array of 3. That gets concated. So now we have this array. And we have that pivot of 4. These get concated. So now we get 1, 2, 3, 4. And this is going to get concated to our RS quicksort of our right side, which was 5. It should return just an array of 5, and that gets added. So we end up with 5. Yeah, Andre.
So the pivot, A, how is it declared, and B, is its array of a single entity? So you're counting the pivot with a single array.
So, okay, so the pivot is going to be the element. Well, for simplicity at the moment, we're just going to make it like the last element in the array. That way. So that's not a good practice, like at the end of the day, because if it's possible to set up like a malicious problem where you can make it do the maximum amount of iterations if you know exactly where the pivot's going to be. So the best thing in the world is to like choose a random pivot, like within the array. But for simplicity, let's just take the last element and make that a pivot. All right, so this is what you're going to write next. So I'll write a little bit of a map, like the other ones. A lot of these sorting ones are like you just have to do them a bunch of times. Okay, so we're going to write function, quick sort, recursive function, base case. When is an array one, whatever, be sorted, I don't care. Right, this is an English class, right? Let's just coding. I make lots of mistakes with coding and spelling words. Okay, base case, when is an array guaranteed to be sorted? Choose a pivot. For now, last element in an array. Find all else to left and store as array. Find all else to right. One loop. And left. Okay, there's your roadmap. I'm going to put this on Slack because I know a lot of you like to write the same thing I wrote. And this will save time. And let's take about 15, 20 minutes. I want to give you guys at least an hour to do whiteboarding, so maybe 15 minutes. Okay, what's up? I didn't notice that at all. Did you raise your hand?
No, let's try to talk about
It's all the oversight.
I was asking about merge as like a thing, where is that coming?
It's we wrote it here. We wrote that right here.
What line?
25. We wrote it right before we did merge sort.
So we're using the listen from the model to
Yeah, so merge sort needs that merge function. It's like a helper function in order to work. Oh, sorry. Whoops. Sorry. Yeah. So when you asked, I didn't mean to say it. I just thought like, hey, I thought I answered. I remember the question now. She said, where are we getting a merge function? And I said,
yeah,
we wrote it right before.
but I didn't realize like we
Got it. Yeah, we're totally using it. So merge sort is going to keep splitting it up until we have just that array length of 1, right? Which guarantees sort of. And so once we've got that guarantee, we can call merge on them. So we can start to merge them.
I understand that.
Oh, okay.
I just didn't understand
Where it was coming from? Oh yeah, we wrote it. Oh, sorry about that. Thanks for following up. It's closer to merge, like that is not this one.
Left side.
Otherwise, for any else, it's the same. Yeah, the first word is still the verb. Well, so we did set up an array. Right. This is what's the next step?
Oh.
No, it's not. I don't really.
Okay, clap your hands if you can hear my voice. All right, so I'm just gonna go through it because I want to make sure you guys have some time to whiteboard. Okay, at least 50 minutes. So I'm gonna do this for 10. Let's talk about this. Let's follow our roadmap here and see if we can get some action. So we say function, quicksort, and we know it takes in an array. It's got a base case. Same base case. This function is very similar to merge sort. So much so that after you've learned all of these and you feel comfortable with them, 6 months from now, when someone asks you out of the blue, you're going to be like, "It says merge sort or quicksort." I promise. Well, if not, then you're bully for you. Like, that's great. Anyway, so we can say if array.length less than or equal to 1, then we can just return our array. All right, hopefully we got that far. We're going to keep calling it on itself, so eventually we need it to stop. And a good stopping point is when our array's length is 1 that's already been sorted. And everything's in the right place at that point. The next thing we had to do was choose a pivot. For now, let's just choose the last element of the array. So I'm going to say let pivot. And I'm going to say the array dot pop. This gives me the last element of the array. Takes it out of the picture and everything. And so now I have to find all of the elements that are to the left of my pivot and all of the elements that are to the right of my pivot. So we can set up 2 left of pivot and just go like that. And we'll find all of the elements that are the right of pivot. So far, yeah, Dane? No, because array.length minus 1 would give us back an index. It would give us back, like if I had an array that was 7, 9, and 6, and I did array.length, which is 3, minus 1, which is the number 2, that's not even in our array. That's going to give us trouble. We want to use that last element, that 6, so that we can do the comparisons.
We can do array at array that
You can, but you have to figure out a way to account for that, and so we don't keep adding. So we don't keep adding our pivot. We want to take it out of the array so that it doesn't get longer than it already was. That's a good question. Okay, so let's iterate through this. All right, so we'll go for that I 0, while I is less than array dot length. Oops. And we say I plus equals 1. And we can check if our element is less than. Actually, I'm going to use for each because that's going to be nicer. Array dot for each. And I'm going to say element. And I'm going to say element is less than pivot. So if our element is less than our pivot, we want to do left of pivot dot push element, else right of pivot dot push element. Questions on that? Okay, that's we wrote a kind of a slick way, but it's good that we get used to seeing different types of code. We're writing that like that in ES5. Cool. And so then, right, then we just have to return. And so we want to keep making our left side smaller and smaller. So we're going to say quick sort of our left of pivot. This will eventually return an array. And we can concat that with our pivot, because we know that everything on that side, everything on this side is going to be less than this number. So it's fair to put that in there. And everything after this number will be on the right side. So we can say concat, and we can call quicksort on our right side. Right of pivot. And then we're done. So we can try it. We go quicksort. And we get it to work. Any kind of quick questions on this before we break into our whiteboarding? Helene?
Is less than or equal to the pivot, then you could say push the element and you would have to concat it at the end.
You want me to push the pivot into the left side?
Alright.
No, because the whole goal is to put that pivot, put at least one piece in its correct place. That's the goal. And so as this keeps going, we're essentially lining up all of the pivots in their correct position. So then when it comes back, it's just pivots. What does it?
If you check random pivots, but just change the variable, it's just that all the code is going to be the same.
Yep, pretty much. I mean, we'll have to like splice into it to get that pivot out of our array. Chris.
I set the pivot to array and array.
So that's all right, with the small exception of I have the concern that since we didn't take it out of the array, we're going to keep adding it with each one, and so we're going to end up with like a much longer array than we started with. Donnie.
For me, the thing that threw me off was I thought for each one allowed it.
They are allowed in recursion. That is a thing that's come up with a few other students as well. Remember we had it with my flapping? Did we have it with merge? I guess not, probably not. But it depends on how we're using it. It also came up in permutations and subsets, I think. Some problems are you do still have a loop. If you're using if you're not calling yourself, like sometimes you just have to kind of know whether or not you need to loop it and call it, how that's going to help. It definitely depends. I can't give like a hard, fast rule for that. But that's a good observation and definitely something to be aware of. Any others? Okay, so randomly split you guys into groups of pairs today. So find your partner and you will do Whiteboarding, if your partner's not here, let me know and we will match you up with whoever else's partner's not here. Your partner's not here? Okay. All right, so any of the problems from the DSA curriculum, cracking the coding interview, anything you guys find that you want to do? I just, yeah, I got, here, people want, they need this stuff. Who doesn't have a partner? Tyson, you're working with Eric. Leo, you don't have a partner? Anybody else not have a partner? Leo, you work with Thomas and whoever you're already with. What?
I don't have a partner either.
Oh, you don't? Oh, Leo, you're with Nikki. Takia, you don't have a partner?
Eric doesn't have a partner either.
I've already matched him up. Okay, hey, Levant and say, let's go, let's get up, we gotta go. I used it right. I'm trying to learn Spanish. That means faster, right? I'm doing Duolingo. I'm on like 36 days straight for it. But I'm still really bad at it. Do you speak? Pretty okay. Oh, Ray's not here? Okay, you join Eric. You're with Tyson, right? So you, Tyson, and Eric.